Hello there. So, in this lesson, we'll be talking about volume. Okay, so what is volume? Well, in short, the volume is the space occupied by any three-dimensional solid. The volume is a solid that is measured in cubic liters, units, but it can also be measured in liters. I'm going to add that later, but you're most likely not going to come across that unless you're doing chemistry. But yeah, but most likely you're going to come across cubic units. That can mean centimeters cubed. That can mean um, meters cubed, or whatever the unit might be. Okay, so here are formulas for different shapes. I assume you memorized most of them, but they're here just for your reference. And the best way to do this is to work on problems. So let's work on the first one. Example 1. Find the volume of a prism. Sorry. Determine the volume of a concrete needed to construct a ramp as shown here. So this diagram right here. So whenever I see a prism, I think of a triangle and then some depth. And the first thing I want to do, well, before you do anything, you got to look at the units. So right here I see 1.2 meters, 2.5 meters, and over here I see 4.5 centimeters. So the first thing you should do, and this is with any course or any math course, is convert everything into the same units. Since there's 2 meters here and there's only 1 centimeter here, I think it'll be easier for me to convert the centimeters into meters. So let me do that now. So let me get my pencil tool, and here we go. I hope it's on blue. Is it on blue? It's good. It's on blue. Okay, so here we are going to convert 45 centimeters. And again, I don't know if I mentioned this, but this is how you do all conversions, regardless of what subject you're in. The only time this conversion doesn't work is for, I believe, temperature. Temperature, that's a different conversion, but every other conversion that you'll ever come across is done the same way. If you look up here, the problem doesn't have it, but the conversion between centimeters and meters, and I'm going to add this later, is basically, I should write over here. So basically, 100 centimeters is equivalent to 1 meter. So I know that. So on this conversion, and you're doing it the same way, you have a line here. What goes on top will be meters. On bottom goes centimeters. And again, I'm getting these values from here, from this. This is something you should already know. And the reason I put meters on top and centimeters on bottom is so that this centimeter, because this centimeter is really on top in reality, this centimeter here crosses out with this centimeter here. And all you're left with is 0.45 meters. Okay, good. Now, the next thing we should do is find the area of the triangular base. So before we do, let's put it over here, 0.45 meters. Let's scratch that out. Okay, so the area of the triangle base, let's take a look here. So the area of the base, and I'm going to use A and an underscore base. That's essentially a triangle. Well, yes, the triangle formula. Do you remember that triangle formula? It is base, which is 2.5, so it's base times height divided by 2. The base here is 2.5. That's in meters. Height is 0.45. And it's divided by 2. I'm going to go down here because I'm running out of space. And that is about 0.56565, and the units are meters squared. Again, an area will always be squared. So we found the area of the base. So we found this part right here, that part there. We found all that, and all we have to do is multiply the area by the depth. This here is the depth. From here, basically from here to here. That is the depth. Okay, so let's go down here. So basically the volume, and I guess I don't have to put any subscript because we know there's only one volume, so no subscript there. So the volume, or you can put ramp, you can put ramp if you want, but in this case you don't have to because we know already. So area of the base multiplied by the depth. I'm gonna say depth. There we go. We know that the area is 0.5625 because we calculated earlier, and the depth, if you look back up here, I have 1.2 meters. So over here, 1.2 meters. I'll put in the units later at the end because if I keep on writing it, it's going to take me forever to finish these problems. And we should get 0.675 meters cubed. Remember, volume is always in cubed. Okay, so that was easy enough. That should take you back to, I believe, even grade school or maybe even grade 9. I think they learned this in grade 9 and maybe 10. Okay, so let's do the next problem. The problem is the same way. And you'll be noticing for a lot of these shapes, you find the area and you multiply it by the depth or height or something like that. So you typically find the area first, and then you just multiply it by either height or depth for most of these formulas. Some of them don't work, but a good majority of them work like that. I think prisms all work like that. This one here is a cylinder. It's also considered a prism. And over here, this is considered a prism as well. So again, for any course you're in, you should always convert everything in the same units. And I believe I'm going to convert feet into meters cubed because meters cubed are, I like meters opposed to feet because it's standardized throughout the world. So let's do the conversion first. So the height here is, right now it's 2 feet, right? And I'm going to do my conversion. So times, and I put a dash across. And what's the conversion between feet and meters? Well, the conversion's right here. Again, I put the meters part on top, which is 0.3048 meters. On bottom, I'm going to put 1 feet because it says 1 feet here. Again, every number is really over 1. I know this is on top, that's on bottom, so I can cross them out, and all I'm left with is meters. So, in this case, I should have about 0. Uh, 0.6, yeah, 0.6096, 0.096 meters. Okay, so I guess now we can cross this 2 feet out, and we can put 0.6096 meters right here. And you know what we forgot to do? We forgot to read the question. So it says here a cylinder container is to be planted with flowers. I guess here's the flowers part. The container is 2 feet high and must hold 1.5 meters cubed. So I can tell right away this is volume because it's meters cubed. Anything that's cubed is considered volume of soil. What is the minimum diameter to the nearest centimeter? So I believe you have to convert it into centimeters. Unfortunately, right now we have it in meters, which is I'll show you how to do the conversion, or you can look it online if you want to do the conversion. Okay, so um, we know what the formula for a cylinder is. So the cylinder formula is V equals, and it's the area of the area. I'm gonna say area of the base multiplied by height. But what is the area of the base? Well, the area of the base, if you remember correctly, it is um, pi r squared and then height. So that's the formula for volume. And if you rearrange it, rearrange this formula, you would end up with R equals V over pi h, and the whole thing is rooted. Okay, let's drop those numbers in. I'm gonna move up right over here. And I'll say R root. The volume is already given to us. It is back over here. 1.5, and that's meters cubed, over pi. Pi is, I'll put some brackets, 3.14, and bracket over here. The height is, and this is here the height, which I calculated earlier, which is 0.6096. That's also in meters, and that should give us a number of 0.885, and that would be meters cubed. And we should probably well, let's find the radius first, and then we'll do the conversion to centimeters afterwards. So we know that the diameter will always be twice the radius. So well, the diameter, I'm gonna say D for diameter, will be twice the radius. So in that sense, it'll be 2 times 0.885. Oh wait, hold on. This is not gonna be cubed. This is a mistake right here. Let me just scratch, or maybe just let me get my eraser, because radius is not a volume. Radius is just a length, so it's just meters. Sorry. And then if you multiply this, you will get 1.77 meters. Okay. And the last thing is, it was asking you for in centimeters cubed, so we should probably convert this into centimeters cubed. So the conversion again is put 1 to 100, so it's 177 meters times, and I believe I put the conversion up here. Oh, the conversion is not there. Well, I'll tell you what the conversion is. The conversion is 100. Well, let me just put the line here. It is 100 centimeters is equivalent to 1 meter. Again, this is really over 1. That cancels out with this. And we get here 177 centimeters is the diameter. Okay, so that problem is done. The one thing I think you might have difficulty with is maybe the rearranging the equation. Just simple algebra to rearrange the equation. I might make a formula sheet for that, but you really should know how to move numbers around and variables. Okay, over here, let's do the third problem. This one's a little bit more tricky, and you gotta make some assumptions here, which they do not tell you. But again, the first thing you should always do is do your conversions, and I prefer to convert everything into meters because meters is standardized. And here's the conversion. 1 meter is equivalent to 100 centimeters. So let's do that. So here is 45 centimeters. Let's do the conversion. Again, I put, everything is really over 1. Every number is really over 1. I put 1 meter on top and 100 centimeters on bottom. And the reason I do that, again, is so I can cross this out with this. And I end up with 0.45 meters. Good. So the conversion is done. The next part to this problem, again, we're trying to find the volume of this staircase here. This is a staircase. You should probably break up this part here into smaller shapes. And the assumption I made in this case was the total, like the height here and the width and the height, or length and width, is about 45 meters, but it looks like they're cubes here. So I decided to divide 45 by 3. When I divide 45 by 3, I get 0.15, 0.15, 0.15. That's the assumption I made, and I'm correcting my assumption. And if you come across a problem like this, then you probably should do the same. So let's find the area of 1 cube. Okay. So the area for 1 cube, and I'm going to use the area. I'm going to say cube in subscript equals length times width. In this case, it's going to be 0.15. And I can square it, but I'm just going to do it like this, 0.15. And that will equal approximately 0.0225. And that's going to be meters squared. Again, it's squared because it's area. You're working with area. So that part is done. Find the area of this entire base. So you will now find the whole area. And I know there's 6 cubes here. If you count them, 1, 2, 3, 4, 5, 6, 6 cubes. So we know what 1 cube is. 1 cube is this amount. So for 6 cubes, so I'm going to write down here area of the base equals 6 times the area of 1 cube, which is 6 times 0.0225, which gives you the value of 0.135 meters squared, because area is always in some sort of unit squared. Okay, so now we can find the volume of the staircase. The volume is essentially the area of the base multiplied by the depth. Okay, so we know the area of the base. The area of the base is 0.135 meters squared multiplied by the depth, which is 0.9 meters. And that should give you a final value of 0.24 meters cubed, because it's volume. Volume is always expressed in cubed. Okay, that's the lesson. I'm going to make some corrections to these notes here. So you may not want to download them directly, like download maybe after a day once I make those corrections, and that's about it. Okay.